And now we've got Sally, who leads the pelagic group in ecosystems in Bass. Sally's more an oceanographer by original training, but becoming an ecosystem person, at least hopefully more and more. But I think many predators think of the ocean as a source of prey, but it's actually interesting in its own right. So convince us and tell us something about the science that's going on in the open ocean. Thanks, Sally.
Thanks very much, Bill, and thanks for having me here. It's my pleasure today to talk to you about the work that we're doing within the pelagic ecosystems team. So as Phil said, this is a picture of the krill-based food web at South Georgia. So we are interested in our team about the interactions that are going on underwater, how the environment affects the distribution of the krill in particular. Is this working? It feels like it's cutting out. No? It's okay? Thumbs up. Okay, great. So right in the centre is a beautiful illustration by an artist called Glyn Gorick that was in a recent paper. And this shows the food web that we see at South Georgia with a bit of extra ice in there that isn't always there. So you can see the krill are in the centre at the bottom here. And we are interested in how that affects the wider ecosystem. One of the things that the paper points out, and I have a duty to point out, fish aren't very well represented in here, but they're a major predator of krill as well. We do a lot of monitoring to understand the krill distribution and how that affects the wider ecosystem. So the long-term monitoring that Ash and has talked about just now, we're trying to relate these series together. So just to convince you about the importance of krill, I know many in the audience have seen them, eaten them, handled them. Here's a picture. So these are the crustaceans. They grow to about thumb size. They're found in vast swarms. So this is a super cool picture. It's old now, but it's from a camera on the top, I think, of a seal head, as it's targeting a swarm of krill, eating the krill in there. And you can see a handful of krill, and then just a picture at the bottom that we put of a krill's head, just because we were trying to engage children in how cool they are. And so some facts about krill then. So they're really numerous. They have a huge biomass. So for every person on the planet, there's around about 100,000 krill. So it means there's an estimate of about 800 trillion krill out there. And that's what feeds this incredible wildlife system that we see on South Georgia. The krill are the basis of the food web, except for the phytoplankton that I'll come to. This picture shows the number of species that feed on krill. So the numbers in the circles show that. So you can see, as I said, 49 species of fish feed on krill. And it's not just the animals that are using the krill, there's the fishing industry there as well. Not only are krill important to the animals that live there, they're also a really important part of the carbon cycle. So we have a biological carbon pump, and krill are a key component of that, partly because they eat so much, there's so many of them, they eat a lot of phytoplankton, their poo, their feces sink quickly through the water column. We had to use American spelling there because it was an American article. And this contributes to taking the carbon away from the surface down to depth. And that's really quite a significant component of this system. And so we're interested in all these aspects of krill. So in this talk, I'm going to tell you a bit about the science that we've done over this last year. I'm going to talk to you about unusual sea ice that happened, some shipboard science that I was lucky enough to go on, and Josh as well was on that cruise. It was quite spectacular. And then another giant iceberg. I think you've heard quite a lot about icebergs recently through the South Georgia Association, and we've had another one that's still around the island actually at the moment. So I'll start with sea ice. I'm going to provide in the next few slides the context to the cruise that we undertook and what's been going on this season. So as I'm sure you're aware, the pink circle there is South Georgia. Sea ice forms and retreats every year in the Southern Ocean. At its maximum extent, it doubles the size of the continent. And sea ice is really important for a number of reasons. It affects the ocean atmosphere interactions. It it buffers this ice shelf so it can help stabilize those. And what's happening is that overall in the Southern Ocean as a whole, we're seeing a decrease in the amount of sea ice each year. So what this graph shows is that the this bit, the grey lines are the long-term average that we see. So this is the amount of the ocean that's covered by sea ice in each month, taken by satellite data. So the grey is what it used to be, 1981 to 2010, so the long-term average. But what we're seeing in recent years is there's a decrease in this. 2023, the red line was the record minimum. So we saw much less sea ice than normal in summer. So this is January here through to December. So much less sea ice in summer and in winter. And actually the most recent years, so 2024 in the black line and 2025 in the blue line, are following these quite closely. So we're seeing this decreasing trend in the Southern Ocean as a whole. But that's not the only part to this story. You know, this is an average all around the Southern Ocean. Well, it's a total. But what we know is that there's regional variability in this. And this year we saw that to an extreme. So what I'm going to do is show you a series of images now. These are from the National Snow and Ice Data Centre. It's satellite data. And what they do is map the sea ice cover. So again, South Georgia in the pink circle here. The darker blue is the sea ice in 2024. So this one's from February. The white is the year before, and the paler blue is the overlap. So what you're doing is following the darker blue colour, and I'll show you how the sea ice progressed over this last season. So February is the minimum in sea ice. That's the southern hemisphere summer. So as we go through, so this is March. So now you can see the dark blue is the sea ice advancing. This is what happens. It starts with this multi-year ice in the Weddell Sea, and it expands through across the Scotia Sea through winter. So this is autumn, March. As April, it's going ahead. So you can see already that what we're seeing in 2024 is much less sea ice, much more sea ice than there was the year before. That's the iceberg that I'll talk about later, so you can keep an eye on that as well. So then as we go into winter, the ice again, it's extending. Darker blue shows that the ice is further north than it has been the year before, and for a long time actually, through to June. So it's approaching South Georgia. It becomes very unusual. So now in July, we're seeing sea ice getting towards South Georgia, and we haven't seen this in the satellite records since I think 1980 and 1987. So it's a long time since we've seen such extensive sea ice. So then as we go through to August, then it's approached the island, and it gets very close, as you can see from this satellite image here. So this is a stunning image, and if you ever want to see satellite data, the NASA Worldview website is fantastic. So you can go on and you can get images such as this, really stunning. So South Georgia, completely cloud-free, which is completely unusual, and this was on the 17th of August, 2024. And so down here, this is cloud, so often we'll see cloud hampering the images, but this now is sea ice, all these white speckles around, and you can see just how close it got to the island. So it's really exciting. It gives us new conditions to study, and it just shows, it again highlights just the importance of long-term monitoring. Because we've got these long time series of data, we can now look at an event such as this and compare it to things in the past and how things have changed this year compared to other years. Then going back again, where are we now? September, so this is the maximum extent typically. You see it's wrapping around South Georgia, and this had impacts for the ecosystem, for the fishing going on, all sorts of things, and we're really excited to study this. And then in October it starts retreating through to November, and then December. So there's still more sea ice in the summer, and then it retreats away. And then as we're going through now into the months just gone by, so February this year, March, and now you can see that it's a bit more back to normal. And by April, May, there's not as much sea ice as there was last year. So we're expecting a more usual year this year from what we can tell so far. And in fact, this is June, so this is just last month. And now this paler bit is the bit that we're seeing. So it's much further south than it was. So that's kind of set the scene for a really exciting cruise already. Another thing that we monitor is sea surface temperature from satellite. So this gives us an overview of the whole region. This is what satellite data is great for. Gives you this regional coverage. And I love these kind of images. It really shows that the dynamics of the ocean, just how variable it is, the features that we get. You can see eddies, there's fronts in the flow. It's constantly moving, constantly delivering new things to South Georgia. And that's one of the things that we think maintains the ecosystem at South Georgia, is the influx of krill from the peninsula across to South Georgia. So because we've got satellite records going back to the 1970s, 1980s, we can look at time series of, in this case, temperature. So this is a plot now of sea surface temperature from northwest of South Georgia. So it goes from 2000 through to 2025. And what you can see in here is the seasonal cycle in the temperature. So warm water in the summer, relatively warm, that is 4 degrees, through to cold winter water. So you're seeing then temperatures down to about 0. And you can see that that changes from year to year. There's a lot of variability in the system there. And that's highlighted by this plot here, which now shows the temperature, but as a difference against long-term mean. And what I want you to take from this is that the 2024-25 season that we've just coming to the end of now was much colder than normal, followed quite a warm period in the preceding years. But we've seen these events before. There have been cold periods. And so the more frequently, not the more frequent, but when we've got repeat occurrences, that lets us tie these data sets together and look and compare between the environment and the ecology. So the last satellite data that I'm going to show before we move on to the ship cruise is phytoplankton. So these are the marine algae, the grass of the ocean, people say. And what this shows, you can use satellite sensors. They measure ocean colour, and that lets you see how much phytoplankton's in the water. So this is a global picture. Green colour is more phytoplankton, blue is less. So you have these patches where they're not as productive, but you can see the Southern Ocean, the Scotia Sea, hugely productive. Lots of phytoplankton in the water, which is that image at the bottom. So I'm going to show you now how the conditions this year compared to the last 2 years. So I'll just explain what I'm going to show before I throw a load of maps on your screen. So, okay, so what I'm going to do is going to show a series of plots along these timelines. So from 2022 and 23, 2023 and 2024, 25. And I'm going to show you through the summer season, and you'll be able to see just how different this year was. So what we know about South Georgia is we get this regular phytoplankton bloom north of the island. We get it every year, but the things that change are when it starts, the spatial scale of it, the distribution, and just how strong it is. So for an example, here's the 2022-23 season. So we start with November on the left. So that's already the blooms started. So the darker green colours mean there's more phytoplankton in the water. So November, then through to December, it's got stronger. It's moved more to the north of the island. January's still there in this year, February as well. The following year, a different pattern. By November, the bloom was really strongly established on the south side of the island and the north. It tailed away in December. January, we got this big wide extent to the south of the island. And then in February, very broad coverage, which is very different to the year before. So then this year, so this is 2024-25. So November, much less activity there from what we can tell. December, there was some of the bloom to the north, but January, this is the thing to focus on. I mean, that's super, super strong, much more intense than we've seen for a long time. And it tails away again in February. So these are all the kind of dynamics that are happening in the ecosystem that we're trying to monitor and understand how this is affecting the whole system, really. So we know that we were going into an unusual year for this cruise. We were super lucky to have ship time on our new ship, the Sir David Attenborough. This was a long cruise. We were at sea for 50 days. We didn't get off. So sea legs were well developed by the end of the cruise. It was led by Geraint Harling and Sophie Fielding from Bass. Yeah, we just had the most amazing trip, and I'll show you more about it now. Okay, so this is our cruise track. here we go. This is the only bit where I've done any kind of like PowerPoint nonsense. So we started here in Punta Arenas. We went around South Georgia. We came across to the South Sandwich Islands. We came down. We went back up here. We came to the South Orkneys. We did a loop and a number of stations here. I went back to South Georgia and then finished in the Falkland Islands. Yeah, incredible trip, an incredible ship, brilliant people, so much science. It's really unusual now to have a cruise that's just dedicated to science without trying to do some logistics on the side. So we were very fortunate. And I'll talk to you, the cruise comprised a number of projects, and I'll show you what they were, but I'll talk a bit more about all these aspects now. So we had around about 80 people on board. That's a lot. I'm used to going to sea on the JCR, which felt like a lot of people at the time, but this is now 80 people. So for all that time at sea, that's the only people that you see, as some of you will know from your time on ships as well. We had a really strong science contingent, a lot of scientists, a lot of different teams, and that's what made this cruise really exciting. Was we weren't just doing one aspect of science, we were covering a lot of things. So we had physics, we had seafloor biology, biogeochemistry and nutrients, phytoplankton, zooplankton, cetacean team that Jen organised, and we had a media film crew on as well, which added in different ways to the cruise. So if you haven't been lucky enough to go to the SDA, and the Sir David Attenborough does come, and we do visitor days on board at certain times of the year, so keep a look on our BAS website. We have a virtual tour on our website. I don't know if you can see, but the website's at the bottom, Virtual SDA, and you can go on and it gives you lots of videos about being on board the ship, and you can see all the different quarters on there. It's a really comfortable ship, really big, 130 meters long, but it is an incredible science platform and lets us do so much. So the cruise then was divided into separate projects. We repeated the Western Core box, which is the blue stations at the top there. I know some of you were there for earlier core box cruises and have maintained them through the time. This has been running since 1996, and this is like another of these really long time series that we're very lucky to have and are very important to keep going. So the aim of that is to look at, oh, it's that bit, there we go, that saved me reaching. So with this, we do these series of acoustic transects with measuring the physics and other properties as well. And that lets us understand variability in the krill distribution at South Georgia. So this work shows the amount of krill in the water column with years, and we see strong variability in that. And we keep this time series going to better understand that. And Sophie Fielding's in charge of the Western Core Box surveys. We had another project called Biopole, led by Geraint Tarling at BAS, and that was for this section of the cruise and this one. So this, as well as the South Georgia work, we took a line down through the Scotia Sea, and this is a long-term repeat section that I'll show you in a minute. But first of all, the Biopole project. So this is a really large multi-million-pound project across a number of centres. And our aim is to understand how the nutrients from both poles, from the Arctic and the Antarctic, are transferred into the global ocean and the impact they have. Because the poles are important beyond just the poles, as we all know and understand. But we're particularly interested in the nutrient fluxes. And the key species that we're looking at for this project are copepods. So that's still a zooplankton, smaller than krill, smaller than a grain of rice. But what's important about copepods are they spend the summer at the surface, and then some of the species do a seasonal migration, and they spend their winter at depth. And that's a really efficient way of transferring carbon down to the seafloor, because what these are in the copepods are big sacs of fatty lipids, and that stores the carbon, and then as the copepods use it at depth, it releases there and keeps it away from the surface. So the other aspect of this cruise is this line here. This is called the A23 repeat section, and it's a hydrographic transect. So that means we do CTDs where we're measuring the physics of the water column. And this is a series of the plots from there with time starting in 1995 when the series first started through to almost present day. And the color code is temperature. So this is depth here and south to north here. And just at a quick glance, you can see that there's differences. And what we're looking at with this section is the amount of bottom water that's leaving the Weddell Sea. So we have this deep water flowing out of this area through the world's oceans, and that's the powerhouse of the ocean circulation. It's important not just in the Southern Ocean, but throughout the globe. It's driving our the ocean circulation and the atmosphere. Really important to monitor it. So we were able to do another occupation of that on this cruise. And then I think this might be the last one, that's number 4. It was really quite a complicated cruise. We have a big program called the UK Polar Research Expertise for Science and Society. And as part of that, we have a mooring up northwest of South Georgia in the orange circle. And that's a string of instruments that we're measuring carbon flux with. And that's what this schematic is showing. So it was called Scoobies. It's now called SOBO, so Southern Ocean Biological Observatory. But what it is these, I'm sure you've seen moorings before, but they're a string of instruments, railway wheels at the bottom. We deploy it into the seafloor, and then the instruments float through the water column attached to this wire. And they're measuring things including krill abundance, collecting phytoplankton. We've got a sediment trap to look at the amount of material that's falling through the seafloor to the seafloor to understand transfer of material. And so we were on there to pick up the mooring and turn it around and put it back in the water to carry on. Because moorings are brilliant, you leave them there for a year or 2 years, and they're collecting data all that time. So when we can't be there with a ship, they're giving us all this additional information. Oh no, there was one more project. So the last one, this is the last one, it's an EU-funded project called Ocean Ice. And so what we managed to do on this cruise was we picked up another set of moorings from here. These are in the South Sandwich Trench. This is a super, super deep part of the Southern Ocean, over 7,000 meters deep. And we had moorings there to monitor the outflow of that deep water that I talked to you about. And this is a picture of the mooring. What I really like about this, where somebody on the cruise put it together, is it shows the scale of it. So this one was 6,000 meters deep, and we had instruments all the way up to 1,400 meters. A massive amount of rope with all these different instruments measuring temperature, the flow of the water. And this is to scale. So here's the Burj Khalifa. So it's just incredible. You know, it's really hard to get that scale when you're at sea to understand just how deep the ocean is beneath you. But several, I don't know, Eiffel Towers and Eiffel Towers of instruments and rope. So we went there and picked that up. We didn't put those back in, but we recovered those. So that's the background. So I'll show you some pictures now from the cruise. So these are the moorings. This is what we were doing, picking these up. Normally, this is how they start. These are big floats at the top of the mooring chain up there, and they have acoustics on the top. So we can look up towards the surface and see how much krill is going over. That's what that instrument there should do. This one is the one we picked up. It's completely covered in gunk and muck because there was so much phytoplankton in the water, it's just rained down and kind of completely covered the instruments. We need to work out what that will show us. And actually what we'll be able to get from this series is, we'll be able to see when the signal started degrading and just when the productivity kicked in. So we had a team of people who, they did volunteer, honestly, to scrub these before they went back in the water. This is the sediment trap that I was saying. So that sits down at depth and the material falls down into it. These cups rotate underneath it and close at a certain time. So that gives us a seasonal signal of the productivity in the water column as well. They're really, really valuable pieces of equipment. So then we did physics as well. So this is a CTD, so it measures conductivity, temperature, and depth. What I should have said was, so this was, first went to sea in 1997 with Chris and Robert both in the audience, which was so much fun. In fact, Paul, it was your cruise. It was the, I can't remember what it was called, the one that went all the way around the Scottish Sea. And CTD is still the same, it turns out. The instruments are slightly different, the sensors, but the operation of it is still the same. So that was fun. And from the CTD, it collects water as well. So then we had a team of people taking samples that can measure for nutrients, the phytoplankton, all sorts of things in the water. So we kept busy with all the CTDs around the cruise. We did the acoustic surveys as well. So this is an echogram from the acoustic. And what we found this year on this cruise was we saw more krill than we've seen in a long time around South Georgia. So we are going to follow that up, obviously try and understand that. What it did mean was the media crew that we had on board, they're producing a series on ice, and they wanted to show the challenge of being at sea and, you know, all the heroics that we do and just how amazing we are. But they really wanted it to be a struggle to find krill. But actually this year, wherever we went, we could find krill. So they were more disappointed. We were excited, they were disappointed. Anyway, that's coming out in a couple of years. So you keep a lookout for that. We'll try and flag it in the newsletter when it comes out. But they did an amazing job of capturing so many aspects of the science. So what's new as well is we've got a net on the a camera on the net that now you can see as it's going through the krill swarms. Unfortunately, the video doesn't work, but we did catch krill in that. Yeah. So these are pictures. So I just want to highlight Dan Mayer was on board, and if anybody's on Instagram, I'm not, but Dan is. He puts the most incredible images on there. These are all images that he took. So this was deploying one of the nets in the middle of a snowstorm. These are krill eggs and larvae and copepods. Incredible. And actually, there's a story in the BBC News today about a paper that's just come out about the importance of zooplankton taking carbon through the water column. It's got some of Dan's images, and it's really worth a read after this meeting. So then as well, we did benthic work. So we had two types of trawl. And we put this down onto the seafloor. So this was another aspect. We don't normally get this on the Western Core Box, but because we had all these different teams around us, we could do a whole range of science. So two different types of trawls, and these are some of the animals that they brought back up. I can't promise they're all from South Georgia because they did some trawls at the South Orkneys as well. They're Scotia Sea benthic creatures, really incredible and stunning to have the opportunity to see those. And then we had a whale observing team on board that Jen organised. So they were up there in good weather conditions to monitor the cetaceans that we saw around the whole cruise track, not just at South Georgia, but elsewhere as well. Yeah, and a real highlight, we saw blue whales, which I've never seen. I was delighted. So that was a mother and calf pair. And just in general, we saw a lot of whales. It was really quite noticeable, the difference from when I last went, which was, well, 20 years ago now, to seeing them now. And the blue whales, yeah, incredible. So this Cam was one of the media team, and he had a drone and got amazing footage. So we did all that, and that was planned. And then we came across an iceberg. So A23A was in the media. It calved from the Weddell Sea 40 years ago, and it's taken a long time to get out across into the Scotia Sea even, and then it's dilly-dallied across the Scotia Sea. Anyway, as we left for the cruise, it was on its way to South Georgia. As you know, there's so much media interest in icebergs at South Georgia. There's such an incredible publicity opportunity for the island, you know, that no matter, and we've seen several in the last few years, there's always a story. The media are always interested in icebergs approaching South Georgia. So this was in January. So we were leaving at the end of January. The iceberg was on its way. We had not scheduled time to take a detour to go to the iceberg. Unfortunate, but that's how it was. But the iceberg had other plans. And actually what happened was this was its trajectory across the Scotia Sea. It spent time here, and it came up and it grounded on the southwest shelf of South Georgia, just as we were heading back to South Georgia to redeploy a mooring. So it gave us a really incredible chance to, I'll just skip that, to do some science around the iceberg. We've done that with other icebergs, and with this one, in fact, but never with the team on board that we had. So we could do biology as well as some of the physics. And this is just a beautiful image from one of the satellites taken in May. Just gives you the scale of not only the iceberg, which is here just caught on the shelf, but the amount of ice that it sheds into the ecosystem. So what we did was this is a really busy plot, but we approached the iceberg from here. we did a really close transect along the side of it. The captain was up and navigating very carefully as we went past there. We went past it to redeploy the mooring, and then we came back and did transects away from it, and then very close around and about. In fact, we got into this kind of fjord in the iceberg here, incredible, and we did some swath surveys around. So incredible data that we're still working up, and we're looking forward to understanding more about iceberg impacts and what we can find from these data. So this was just pictures of us in that area. So we deployed the bongo nets to look at the zooplankton in the water. We did the CTDs close by. We picked up some ice. So that's the part of the iceberg there, so that we could take samples and look at nutrients within the ice and better understand the impacts. Oh, and this was the media team, and I never got comfortable talking to the camera. It was quite an experience, but they worked really hard, and if it comes off and it goes to air, then it should be a stunning documentary. So as well as that, we've also got other science going on. These are the science projects at King Edward Point, operated there. I'll just quickly show you some of these that link in with the work that we're doing. So we've seen this figure already, but these transects are part of an ongoing survey now, done every 2 months at South Georgia, an acoustic survey, net samples, and cetacean observations to understand how things change throughout the year. So this is a really big advancement for us to have these data, not just in the summer when we can get a regular ship there, but through the year, and it's following on from the Winter Krill project. So yeah, that's those ones. So these transects are covered regularly off the Pharos, so amazing support from the Pharos. And then we did well, there was an extra 2 surveys done in winter, I think, Martin, was it September time? 2 extra surveys done here when we knew there was more sea ice around and more krill, just to better understand what was going on. And then, just the last project I'm going to highlight is one called the Pelagic Biodiversity Project, and that's funded by Darwin Plus. And what that is, so this is us moving now to understand more about what's in the water. This is looking at not just krill, but understanding all the other zooplankton and fish that are around. So that's by doing different nets, number of nets, taking water samples, and a super cool bit of equipment called an underwater vision profiler that takes imagery, and that will let us see just what's in the water and match it with some of the other data that we're collecting, including DNA samples, so eDNA from the water, which lets us see what's been there and gone past. And then the last thing, I keep saying the last thing, but I think this probably is, the groundfish survey was occupied this year. So Martin's provided these slides. Martin was on board. They did a number of trawls on the seafloor to better understand the distribution of mackerel ice fish and Patagonian toothfish, and this guides the management decisions that go in there. It's a biennial survey, and part of it is that they tag toothfish and then re-release them to understand population dynamics. So again, another time series of data. I feel like that's Christmas music. So that was completed this year and will be done in 2 years' time and gives us additional data to understand what's happening. So, as preceded by the bongs, here's my summary. It was a bit of a whistle-stop tour. We did a lot of science this year. We were super fortunate to get the amount of ship time that we did, and that really enhances what we're already doing in the long-term monitoring time series. The value of those just can't be understated. It's so important to us to have these data that let us understand what's going on and will enable us to predict into the future as well. We're using more and more technology, as everybody else has already said today. You know, all the different sensors, the instruments, it just gives us a wider view of the ecosystem. And yeah, just say thank you very much to everybody that made the science possible, the scientists, the IT support, the ships, everything that went on. So yeah, thank you very much.
Thank you, Sally. That was a real whistle-stop tour. There is an enormous amount of data there. So what's the sort of expected time before we start seeing some of the publications from that? It's going to be a while, I imagine.
Yes, so it takes a while to work up any science, but one of the things that it puts a little delay in the system is that all of the samples are on the ship, and so we need them to come back to the UK before we can start analysing them. And this year we had, it was in the news, maybe you saw, the ship was down south for later in the season than it's ever been before. In fact, it was there for midwinter, which midwinter down there, midwinter down there, midsummer up here, which we've never had before. So that means there's a slight delay in the samples coming back.
Yeah.
But yes, we're looking forward to working out just what to tackle first and how to do it.
So one more quick one from me before I open the floor. The Western Core Box and a lot of the long-term monitoring, that's really hard to sustain in terms of resources, personnel. How challenging is that going to be into the future?
Yeah, you're right. It's a big challenge for all those reasons. But what we're trying to do is just demonstrate the value of these series. They're so important. And we've got support from us for that, and we want to keep that going. But yes, there's issues with personnel, just keeping the skills there, and getting the ship time as well. But you know, we're able to use the Pharos when we can't use the Sir David Attenborough. That's got an acoustic echo sounder on now, so that adds to the ability to keep that time series going. And we're just looking for the opportunities where we can. We're going to be doing it again this coming season on the Sir David Attenborough. We'll be trialing new equipment, so it's really exciting. It's still evolving, and we're adding more to it as and when we can.
No, I mean, there's some great data sets, so I'm really pleased that it's still going.
Yeah.
Any questions? Okay.
Do you still work with the Navy?
So yes, when we can. Yeah, there's still links, particularly with the surveying, so the seafloor surveys, the swath. We've the RAF did a number of fly pasts over the icebergs. We were able to get more imagery from that. So yes, we do as and when we can. There's still strong links there. Yeah.
So do you have any feeling as to how long H23 might last before it breaks into normal?
Yeah, normal, that's right. I didn't really talk about scale. So it's it could vary. Yeah, no, we don't know. We thought because it's taken so long to come across the Scottish Sea and it did those twirls in the ocean for a long time, we thought it would be weaker and it might have collapsed by now. There'll be a bit more stress on it from having been grounded. It's now southeast of the island, following the typical route around the island. So expect that it'll just get swept past. But yeah, how long it'll last, I'm not sure. It's drifting again now. Yeah, it set off end of May, and it's making quite a rapid route around the island. So it may well not ground again. It might just carry on, or it just depends on, you know. So icebergs of that size are generally their movement is through the ocean currents rather than the wind. As much as when the smaller ones, the wind's more important. So it's possible that unless a big storm comes and the water does something different, it should just move through now. But we're keeping an eye on it and trying to understand, because it's like that picture showed, it's not just the actual iceberg, it's all the bits that are shedding off there, which, you know, they affected the fishery at times. And yeah, so, but the satellite data just lets us keep an eye on it in ways we've never been able to do in historical times. So yeah, perfect.
How come the master was allowed to go into that little crack in the iceberg? I was amazed to see the track going in there.
I know.
He was brave.
Yes, he was. But actually, we made quick exit from there because not only were we worried about bits falling off, the currents were really strong in there, and we couldn't hold position very well. And the nets that we wanted to do were just drifting off. So we moved on quickly. But what an incredible opportunity! It was so you know, we talk about serendipity and how things are fortuitous in science, and that really was it. So yeah, incredible.
Really unusual data coming from
really unusual. Yeah.
Any more? Great. Well, thank you, Sally. That's really nice.